Okay, so we can start now. So we won't follow the order. We follow a certain, won't follow 1, 2, 3, 4. That's going to move up. Okay. This topic was also something else. Okay, let's start with question 3. Please put your phone there. So, question 3 reads, the temperature at the bottom of the 40-meter deep lake is 12 degrees Celsius, and at the surface it is 35. An air bubble of volume 2 cubic centimeters rises above the surface. What will be the volume, given that atmospheric pressure of water is 10 meters? So this is what we need to know. So let's just make an assumption and say let's P1, V1, and T1 be the pressure, the volume, and temperature. So let these be pressure, volume, and the temperature. Remember, we're looking at two things, the initial and the final. So one will represent the initial. This is question 3. So, the absolute temperature at the bottom of the lake, we're going to use the other ones now, which is P2, V2, and T2. So it's just a matter of the gas law equation for this one. So we know that the gas law equation is given by P1 V1, P1 V1 over T1, which is equals to P2 V2 over T2. Like that, simple as that. That's what is known as a combined gas equation. So if we go back to the question, it says what will be the volume after it rises? So we're looking for volume 2 in this case. So since we're looking for volume 2, let's make volume 2 the subject by cross multiplying. What do we get? We'll get P2V2T1 is equals to P1V1T2. So we're making V2 the subject. So V2 in this case will be equals to P1V1T2 divided by P2 and T2. So P2 T1, sorry. So divide both sides by these two, then they just go that side. So at this stage, it's just a matter of replacing. Let's go back to the question. We see the values we've been given. So the question says the temperature at the bottom is 40, at the surface it's 35. So at the bottom, it's not 20, sorry, it's 12. And at the top, it is 35. One thing you need to know is that when you're using this gas law equation, always change your temperature from degrees Celsius to kelvins. How do we convert to kelvins? How do we convert to kelvins, if you remember? I think there's a question on temperature conversion. So converting to kelvins, the formula is the temperature you have in degrees Celsius plus 273. This is equals to your temperature in kelvins. So these values that you see here, just add 273, 273. Then you have your temperatures in Kelvin. So 12 plus this should get 285. This is in K. We add these two, we should get 108. Sorry, 308. 308 kelvins. So our temperature 1 is 285, our temperature 2 is 308. Why are we doing this? I said whenever we're using the combined gas law equation, always change your temperature to kelvins. Okay. From there now, let's talk about pressure. Since we've been told that the pressure at the bottom of the lake is 40, and then at the top, we're going to use 10. So we're going to say pressure 1 at the bottom is 40. So pressure is being measured in terms of meters. Plus the one for water, which is 10. So pressure 1 will be 50. Pressure 2 at the top, so it's just water, which is just 10, like that. What else do we need? The volume, which is V1. So volume V1, if you look at the question we've been given, the volume of a bubble as it rises is 2 cubic centimeters. So V1 is simply 2 cubic centimeters. So there's no need of changing to square to cubic meters because the answer that we're looking for, we'll just use the same units. So with these values that we have, just replace here. Tell me what you find as the volume 2. Just do the replacing. Okay, so go to the question. At the beginning of the question says the temperature at the bottom of the lake is 40 meters. Sorry. The temperature at the bottom of the 40-meter deep lake is 12. So 40 meters deep. Now, the last statement again says the atmospheric pressure of water is what? 10. So at the bottom of the lake, which is 40 meters deep, the pressure is what? 10. That's why we add the 2. For this one, pressure 2, it's at the surface of the water. So the pressure of water at the surface is just what? 10. Because it's at level ground. Yes. So just do the substitutions. Tell me what you get. What are we getting? Okay. $10.8. Yes. So once you do your substitutions, you find our substitution will be 10.8 cubic centimeters. Simple as that. Okay. I hope we're getting the same answer. Let's do question 6. It's similar to this one. The one which has the gas law equations. Question 6. We'll do everything, don't worry. Question 6. Let's see if we have learned our lesson. Question 6 says, yes. Because we didn't change them. If we had used cubic meters, then here we need to use cubic meters. That's the idea. So we didn't change them, so we maintained them. Look at this. You see pressure? What's the unit for pressure 1? The unit for pressure 1. It's meters, right? Pressure 2, what's the unit? Meters. So this meter and this meter will cancel. Temperature, Kelvin, so they will cancel. But for volume, it won't cancel, which is a cubic centimeter. That's why it will maintain the cubic centimeter. So you can't use cubic meters. We have to use the same unit. But there's no harm in you changing the unit here to cubic meters, meaning that even this will change. But as it is, it's okay, just like that. Yeah. Question 6. A metal barrel filled with air and is closed firmly when the pressure is 1 atm. And the temperature is 20 degrees Celsius. On a hot sunny day, the barrel's temperature rises to 60, while its volume remains at most the same. Find the final pressure. So for this question again, like I said, as long as you're using this formula, Temperature must not be in degrees, it must be in kelvins. So those two temperatures, let's start from there. Convert them from degrees to kelvins. The formula is there. Convert them from degrees to kelvins. Okay, let's read the question with understanding. So a metal barrel is filled with air and is closed firmly when the pressure is 1 atm and the temperature is 20. On a hot sunny day, the barrel's temperature rises. So this is what we're saying. We have this barrel. You can just use a container in place of the barrel, is fine. So this barrel is filled with a pressure, which is P1 of 1 atm. Okay. Then if that's the case, we've been told that the temperature T1 is 20, which is the same as 293 kelvins. Is that okay? Now, on a hot sunny day, what happens?